Lifeline? Oh. Figure out what that was, because I don't know what it was. It didn't pop up. You know, I think I know why it didn't pop up. Hold on. Yo, Nuts, thank you for the gifted. Thank you very much. I appreciate it. Glad to see that the blurp sounds are working again. Give me just 1 second. All right, let's get these fixed. So I think what happened was I need to have this lower than my overlay. Replay. There we go. I don't have anything set up for subs yet, so it's just default.
Oh yeah.
Oh yeah. Oh yeah. Oh yeah. So I don't have anything set up for the subs yet. I do have I did change the follows, and I did change the tips.
Where's Michaela at?
Who the fuck is Michaela?
I mean
Mikey? Mikey be doing whatever the hell Mikey be doing. 98% of the time, Mikey is working. And then plus, he's not really interested in the coding stuff anyway.
Brother's always on side quest.
There's always on side quest. I think that's the main quest. Not even the side quest. That's the main. Oh, man. Oh, boy. The dogs choose right as soon as I go on that it is time for Barkies. Okay, so I have to start off by formally apologizing. We started all of this as a daily challenge. That means that I was not supposed to have a single day off. This was supposed to be daily because it's only 1 to 3 hours is my typical time to do coding. I don't do coding all day. I just do a couple of hours. So 2 days in a row, I missed it. Things have been very hectic. You know, there were things that I just really needed to prioritize over doing the stream, and these things just took hours upon hours upon hours to do. So unfortunately, I was not able to keep my end of the bargain the last 2 days. And then the day before that, we kept getting really, really stumped in challenges. So when I started all of this, you know, I did make sure that everyone was aware that does watch the VODs or, you know, watches this in the future, or, you know, it's just the handful of people that I'm very grateful that do come by each day, or every other day, in Nuts' defense there, because he's not here every day, but he is here like every other day, which is awesome. That we might get to challenges and I still may not be to where I need to be, so that way we'll have to kind of like redo a basic course. So what I ended up doing is, if we go back here, we just can't do the last 2 challenges of the basics on the other one. I went through a little bit of what we already done, like things that I already know how to do. So I went through a little bit of this just to kind of try and catch it up to my weak points. And then this is like the official Coddy JavaScript course instead of a course made by somebody else. I feel that the challenges that the other person did, I feel like he took more of an approach of like experienced coders / software engineers. I feel like he had those people more in mind for the challenges compared to people that are just freshly learning, or people like me that have a hard time learning but is trying really hard to learn it because you really want to. So yeah, I don't know what's up with these dots. Like, do the dots mean I haven't done them? Well, I can't get to this one. Yeah, I gotta do my masteries. Okay. Gotta do the mastery stuff. So some of this stuff is just gonna be stuff that we've already done. So bear with me. Write a code that initializes a variable named x with the value of 3.14.
Provided as nets.
Yo.
BRB
Be right
in 10.
back in 10. I believe you. I believe you. Okay, did that get rid of the dots? It did. It gave it a check mark instead. Okay, so. Alright, store the string hello, welcome to JavaScript in a variable called greeting. Greeting. Let greeting equal hello, welcome to JavaScript. I guess it wants. Is it declared somewhere already? Oh, const greeting equals. Hey, hold on. Greeting equals hello, welcome. Good job. What on earth is going on right now? The output is literally the same. Copy this just in case. Paste. Yeah, running the same code again. Yeah, I didn't think that worked. What? What is going on? Mind blown. In the casing of the word JavaScript in your string, it should be exactly JavaScript with an uppercase S. It should be. Okay. Alright. It's usually always something silly. Alright. Got that done. Over here to this one. Declare a variable. Let is logged in equal false. Back to journey. Got this mastery challenge here. Oh. But not all of them follow proper JavaScript. Let username equal John. Let second user equal Jane. Let last login time equal let total sales. Let user name equal Mike. Let product ID plus number. Let variable reserved. Let item price equal number. Let is logged in equal true.
Quanticus.
Yo,
Yeah.
Quanticus! We might be able to do those challenges today. Let days of week equals 7. Special offer. Give me 1 second. All right. Sorry about that. Things are a little hectic still sometimes, but we're working through. But welcome back, Quanticus. Welcome. The challenges have been very difficult without you. Okay. Identify username has already been declared. That is true.
Provide a desnuts. I'm back.
Welcome back, Nuts. Welcome back. Okay, last login time does not follow the naming conventions. So I'm guessing that there is that. Okay, so we have
Quanticus.
total sales does
variable
follow.
Name starting with underscore usually indicates a private variable, so it's used sometimes.
A variable name string starting with an underscore usually indicates a private variable, so it's used sometimes. Thank you for letting me know. Thank you. Okay, so total sales was here. We can use the $sign. Item price with a $sign after is allowed. And underscore is logged in, which you were saying there. So it'd be a private variable. I would like to learn more about those. I imagine it's pretty self-explanatory, but that would be the first time I've heard of that. There we go. Alright, Quanticus. You want to help me with that big brain? You want to help me with that big brain? We can move out of all of this and we can move back to the final challenge. Been promoted to Challenger League. Hey. And we're already to level 2 in the promotion zone. So we're about to be in level 1 definitely by the end of the day.
Quanticus.
Sure.
Let's
get cracking. Alright. So, like I was saying before, I think it was right before you came in, I think that the person that made this modern JavaScript for beginners, Jack Biofred, I think he was really good with what he was teaching, except for like a couple of points that you found throughout, and then a couple of typos that I found throughout. I think that with the challenges, when he made the challenges, he was thinking more of people with more experience, that was more or less taking this as a refresher instead of a like learning from scratch. So I feel like these last 2 challenges are definitely more boggling than they should be. So our challenge here is you're given a function called substitution that takes in 2 parameters. One that is key, which is an array of 26 letters that should be used as the key to the encryption. Parameter number 2 is message, and it's the original text that you have to encrypt. Your job is to write the code that will encrypt the text and store it in a string. Return the string to complete the function. Feel free to write other functions as well that you will use in the main function. Now, I did originally start this with 2 for loops. One for key and one for message, but I wasn't quite sure that we were going in the right direction for that. So we did our for loop, um, that checks for the message length. Give me 1 second. All right, sorry. So we took the for loop. We checked for the message length, adding 1 to I each time. We declared character to equal the message index and the key index inside of the loop. So we do return both as so. But I wasn't really quite sure where to go from there. Like I said, I did have 2 for loops, but I felt like that wasn't quite right. What ideas can we throw out there to get this old brain to understand what to do?
Quanticus.
Does it say
how it wants it to be encrypted, and are you familiar of the UTF-8 encoding for letters?
Does it say how it wants to be encrypted? Just the first index of key needs to replace the first index of the message. But if that letter has already been encrypted, it needs to be the same. So like the message is hello world. So when you get to the L's need to be the same encryption that the index was on for key. You know what I mean? And am I familiar of the UTF-8 encoding letters? Not at all. Now, personally, Quanticus, if you also agree with me that these challenges are probably a little too far for somebody that would be doing all of this from scratch, I will gladly skip this challenge. But it was my own personal my own personal opinion that this feels further ahead than it should be. Like, I'll gladly switch back over to the Coddy course instead, which we're also just taking from the beginning. Left my drink over there. All right, while I wait for your response and your opinion on the matter, I'm going to grab my drink real quick.
Quanticus. These feels like a good challenge to do, but the requirements seem a little esoteric. Like, why aren't they L in Hello World encrypted?
Sorry, I ended up taking a parent break and didn't put the parent break up there. I was only supposed to get my drink. And then I forgot my drink. So that's why you saw my avatar fix itself and then disappear again. Alright, this feels like a good challenge to do, but the requirements seem a little... Sorry. My vocabulary is not that good. That's a big word. Like, why aren't...
Quanticus. Yeah, this should be a good little challenge to do.
Okay. See it now. Should be a good little challenge to do. Okay. So let's start off with, do I need a for loop for key and message separately? I feel like I don't, because technically I can loop through both strings fine.
Quanticus.
Just one loop should be fine. Okay.
Should be fine.
That's what I felt like when I kind of reverted everything back. Because technically, if I wanted to, I could declare another variable and have one variable equal the message, take in the message index, and then the other one take in the key index separately. Which I'm guessing is something we're probably going to have to do.
Quanticus. But the brute force way would to hard code the relationship of a letter to the index number, like A equals 1, B equals 2, etc.
Okay, but the brute force way would be to hard code the relationship of index, like A equals 1, B. So like H would be N, E would be Q, L would be X. I don't quite think it's going for brute force. I could be wrong though. Well, it can't be brute force because I imagine, I could be wrong. I don't know why these are still a secret. I'm VIP now. I imagine that these probably
Quanticus.
change it.
You're only associating it with the number instead of the letter in the key itself.
Really? Okay, so like index 1, 2, 3 instead of physically the letter. Is that if we brute force it?
Quanticus. So A will always equals key 0.
So A will always...
Quanticus. So the numbers will range from 0 to 26. Quanticus. I mean 0 to 25.
Okay. 0 to 20. Okay, yeah, key is an array of 26. 0 to 25. Okay. So how would we go about that then? Just a bunch of lets?
Quanticus. The description of making a separate method to use should give a bit of a hint.
Okay. I'm gonna call the function brute force. That takes
Quanticus. So you can write a separate function to give you the associated key's index number based on the passed in letter.
Okay. Alright. So we're for looping. For a separate function associated key. Give you the associated keys past them letter.
Quanticus. The brute force function can just take in a single letter and nothing else.
So that should be for key.
Quanticus. The brute force function doesn't need to know about the key.
Oh. Okay, so message then.
Quanticus. It takes in a letter from the original message.
Okay, gotcha. Put that back in there. Take this. Take that away from that. Alright. Alright, so as of right now, we're getting
Quanticus. Not the whole message but just a single letter.
not the whole message, but a single letter. A single. Oh. Okay. Alright, hold up. I remember how to do this. Maybe. Alright. So we don't want to console log in the loop. Okay.
Quanticus. So when you call it, it'll look like brute force, message I.
Oh, you can do that? No. Oh, it did not like that. Oh, what? My brain did a funky. All right. No, it wasn't just me. No.
Quanticus. You're not looping through the message inside brute force. Imagine when you call it, it'll essentially be like brute force, A, and then it will return a single number corresponding to the index of the key.
Okay, so we're not looping through. You're not looping through the message inside brute force. Imagine when you call it, it'll essentially be
Quanticus.
like.
So calling brute force, A, should return 0.
When you call it, it'll essentially be like brute force. And a single number corresponding to the index of. So calling brute force A. So if. No return number corresponding index. Oh man. Quanticus, this is why you're the smart one. So if when you call it, it'll be essentially be like brute force pass an A, and then it'll return a single number corresponding to that index of the key. So if
Quanticus. You can either do 26 if checks or use a switch statement with 26 cases.
Okay, I was afraid of that. All right. So if we'll see if we remember how to do a switch. The switch. I don't remember how to do. Switch statement. All right, switch, expression, case, and break. I remembered case. Remembered break. So switch. So what is our expression? Our expression message? Case 0. Case 0, not equals. Message A. Break. I don't know if I'm doing that right. Give me one sec.
Quanticus. Pause. Describe what this function should be doing. What are you checking for and what do you need to accomplish for each case?
Oh, I'm getting yelled at. Got yelled at by Quanticus. All right, pause. Describe what this function should be doing. What are you checking for, and what do you need to accomplish for each?
Quanticus. The way you have it written now says in the case that message equals 0, set message equals a.
So, okay, so case equals. Okay, hold on. I'm understanding what you're saying. I'm just trying to figure this. Oh. Okay. Okay. So if message equals A, then set message to F.
Quanticus.
That
That
A
A will
will
need to be in quotes or else it'll think you're referencing a variable.
True. True. But what if it changes the key later? Oh, wait. So H, if expected output is F.
Quanticus. Yes, so this function has nothing to do with the key itself.
Oh. Okay. But we need to change that.
Quanticus. Only the number associating to the index of the key.
Okay, so this function has nothing to do with the key itself, only the number associating to the index. Do we need to change the case, that message. Oh, the way you have it written now says, in that case, that message equals 0. Set message to A. Really?
Quanticus. So when the letter is A, which index of the key do you need to reference to get the encryption?
Oh, okay. So in the case that the letter is A, need to set the encryption. So 0? Yeah, 0.
Quanticus.
Right.
Right,
Okay.
0.
If case is B. Alright, now you got my brain thinking. Message equals 1. Break. Bear with my semicolons today. They are non-existent.
Quanticus. So when the letter you pass in is A, you want the function to return a simple 0, right?
Right. No. Yes. No. 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 Maybe the answer is not no. We should be proud that I'm even using a switch. Saying. Ooh. Ooh, ooh, whoa. What happened there? Wait. I also figured out an issue. So, also, there's a few more things for it. So, if it's lowercase, it needs to stay lowercase. If it's uppercase, it needs to stay uppercase. It cannot include... Well, I mean, I guess if we're declaring the cases for letters only, it wouldn't interact with spaces and the special characters. So I guess that would help bypass the special characters issue. But like hello
Quanticus.
world.
What does setting the message here to a number do for you? We'll take care of the upper and lower case after.
Okay. I just didn't know if we'd run into an issue. All right, we'll continue to. We'll continue this. Case I message 8 break. Okay. Fine. Break. Okay. Then L. Case M. Oh. So it's 13. It's the most eventful challenge we've had yet. Oh. So 15. So 15. 16. R. S. S. Break. Oh.
Quanticus. I do realize that checking for upper and lower case doesn't have a built-in way in JS. We may have to use the UTF-8 ASCII code after all.
I do realize that checking for uppercase and lowercase doesn't have a built-in way in JS. We have to use C. I am here for the ride. That's the W. Bye.
Quanticus. Capital AZ is 54 to 90 in SCII code and lowercase az is 97 to 122.
Oh God. Okay. Capital A to Z is 54 through 90 in SC. 90. Oh. I don't know what any of that means. We can't always use the AI for a hint. But when I have you around, I feel like I never have to hit that button.
Quanticus.
JS
JS might automatically convert
it
it for you, so if you do, if a letter is equals a and.
Okay, hold up. JS might automatically convert it for you. So if you do, if a letter is greater than equal to A and less than equal to Z, then you know it's uppercase. Really. And then I imagine if you do like else than message index dot the lowercase. I mean, can we not use the two uppercase to lowercase functions in this? Components? What do you call them? They're functions, right? Will be to go letter by letter and encrypt it.
Quanticus.
It's a letter, or leave it be.
Probably
if it's a
can't
code.
do a simple else cause it doesn't cover the special characters which falls outside both ranges.
Oh, okay.
Quanticus. You can use to upper just for the sake of the brute force function though.
Okay. Where would I put that at? Not in our switch, right?
Quanticus. Outside the switch but before
Outside the switch but before it. Okay. So pretty much we're going to want to uppercase all of it. Imagine I did that correctly.
Quanticus. Might have to do message equals, since it gift uppercase, mutates the original letter.
Message equals the uppercase. Might have to do message equals since I don't know if to uppercase mutates the original letter. Okay.
Quanticus.
Also
You also still need the
message
message
in order to use.
in order to use to uppercase.
Oh, okay. So we still gotta pass that in. Well, still fairly new stuff to me. Hyper thinking.
Quanticus. It's message dot to uppercase.
Oh, message equal. Okay. Message equals message uppercase. At least we were almost there the first time. We just fell further off. Message equals message dot to uppercase. So message is going to store the to uppercase. Yeah? Variable. So we're gonna need an if statement in our for loop.
Quanticus. Right now you aren't getting the number back from the brute force function all, you're just setting message to the number inside the function.
Alright, so right now you aren't getting the number back from the brute force function. You're just setting message to the number inside of the function. Now you aren't getting the number back. Force function. Oh, do we need to do more to the brute force function now? Now you aren't getting the number back.
Quanticus. What does message equals 0 doing for you?
So if the message letter equals A, then message equals N is what I'm hoping.
Quanticus. Is that what you want?
Do I want A to equal N?
Quanticus. The whole goal of the brute force method is to return that value.
Oh, my brain is broken. Okay. So we need a return statement, I'm guessing.
Quanticus. What does message equals 0 doing? How is it helpful?
Message equals 0 doing. How is it helpful?
Quanticus. You never atches message again after that function call.
Oh, thank you. Okay. So after all of this is said and done, we're not accessing message. So we need a return message.
Quanticus. You can just do return 0 inside the case.
So instead of message equals 0, return 0? Sorry, I'm still very iffy on switch statements.
Quanticus.
In that
In the
case,
case
that the
that
letter you passed in is
A,
A.
just return 0. Quanticus. Does the brute force function make sense to you?
No. I wish it did. Okay, so we have our cases. So if the message index is said letter, we're going to return the number instead.
Quanticus. Do you understand what it's doing and what it wants to accomplish?
You can let me know if what I said was right. I'm guessing we're returning a value to use to just grab the value out of the key later. Pretty much saying that that letter equals this number, and then have something that just grabs that number from key. Is what I'm guessing.
Quanticus. Say you have a letter from the original message, which letter in the key do you look at? The brute force function tells you the index of the key that you need.
Okay. So in my brain, my explanation was right. I could have worded it better. Give me 1 second. I got children running around where they shouldn't be. Okay. Say you have a letter from the original message. Which letter is the key? Which letter in the key do you look at? The brute force function tells you the index of the key. Okay, yeah. Yeah, we read that. Return. Return this. Shut up. Oop. Return this. Take that out. Return this. That out. Okay. We have a bunch of returned numbers now. So now we're back to this one. All right, so we have a for loop that goes over message length. So we need to brute force message so we can get those values. And then use said values to access the key, to access what's in the key. And then return something that brings, or that displays the encrypted message as a string. So we're going to say if message I equals or do we even need to do that? Do we need to do an if statement for that, or do we just throw in the brute force? Since it takes in message and it's already got a bunch of if, you know? It just says hello world. Definitely not doing that right.
Quanticus. You're calling brute force with the entire message when the function expects a single letter excluding special characters like. Incandescent strut 6YQQW. best viwares on streambo.com, remove the space, at subjafsjape.
Okay, we are back to taking one letter at a time. Let's pick a single letter. Back to a single letter at a time.
Quanticus. Put all of line 4 in a console log and see what you get.
Okay. I don't know if I can do that. Let's see what we get. Okay. So we got our special characters are undefined. So is there something in our, I guess technically in our switch we could do a
Quanticus. What do those numbers mean to you?
Those are our hold on one second. All right. Oh, I didn't mean to do that. Okay. Sorry, it was bothering me. I knew it was something we could fix. So those are the numbers that are associated to what we need to use for our key.
Quanticus. You can't account for every special character, so you just need to check that it is a letter right.
Right. So if so if so the
Quanticus. If it's a letter, then do the brute force. If not, then just place that character in the encoded message.
Oh. Okay, so we don't even need that in there then. If it's a letter, then do the brute force. If not, then just place that character in the encoded message. Alright, so if is okay, so this is where I get confused. Maybe not. If brute force message index is greater than
Quanticus. If it's a letter, then it needs to be either
equal
between AZ or between AZ
yeah.
right.
Then do said thing.
Quanticus. What you're doing can work too.
Okay, good. I was hoping so. Okay, so if brute force is greater than 0, then I imagine we're going to need to declare a variable for this. Then let's bring well, no, not right. If brute force message I is greater than or equal to 0, then run brute force. But we need more than just that.
Quanticus. To prevent having to write brute force message I over and over, you can set it to a new variable. Your intuition is right.
Oh, okay. Yeah, what should we name it? I know we can name it anything.
Quanticus.
Key index.
Key index.
Okay. I just wanted it to be something that makes sense. Message I. Okay, so now we can call key index. Okay, what did I do wrong here? What is it yelling at me about? Else.
Quanticus. You can put key index before the if statement, and then use key index to check for equals 0.
Hold up. And put the key index for the if statement. Okay. So, put the key index before the. Alright. Then we can get rid of all of that. Key index. 2. Won't need to declare that anymore. Won't need that extra parenthesis there. Alright, cleaned it up. Alright, so now key index is storing the message index from the brute force. So if key index is greater than or equal to 0, then okay. So up there, it currently just equals
Quanticus. So if key index is equals 0, which means it corresponds to the index of the key, then use that key index to access the key array to get the encoded letter.
And key index might be doing this wrong. Index equals if key index is greater than or equal to 0.
Quanticus. How do you access an array with an index?
How do you access an array with an index? Yes.
Quanticus. Array index right.
Right. Yeah, so it's key I. Right?
Quanticus.
If key
If key index is 5,
you want
the fifth index of key. Quanticus. I only depends on the loop iteration.
Oh, okay. True. Okay. So if key index is 5, you want the fifth index. Yeah, you're right, because I is in our loop. Length. I still feel like I'm getting that wrong. So, the key index, it's message I, so say that's 5. It would be 5 equals 5 plus key dot length. That wouldn't be right.
Quanticus. You don't need the length of the key.
I read it out loud. I probably was saying that as you said that. Okay, hold up. So key index is 5. 5 equals E. Why am I drawing a blank so hard? I did not mean to type that one. That was a finger spasm. Oh. Interesting. E. E.
Quanticus.
Index.
I'm saying you already have the index in key index, so just use that to access the key array.
Did I do that right? I think you already have the in key. About to access key array.
Quanticus.
Good.
Good. Now key index gives you the encoded letter. Now what do you want to do with that letter?
Okay, good. Now key index key letter. No. That letter. Store it in another string.
Quanticus. Yeah, you probably want a variable to hold the encoded string and add to it.
So here, grabbing key index and ring key index. Log key index. No, that's wrong. Defined. Oh, string.
Quanticus. You're adding the encoded letter to key index, but why?
Okay, hold up. You're adding the encoded letter to key index, but why? Because if the index is a number, then we need to add from 0 to get to that index, right?
Quanticus.
If
the key index is equals 0, add the encoded letter to str.
If the index is greater than 0, add the encoded letter string. If key index is 0. Is that not what we have? If key index greater than or equal to 0, add the encoded letter to string.
Quanticus. Key index serves its purpose by letting you access the key. You don't need to add to it or anything.
So just key index equals key index. Oh, I did not like. The index serves its purpose by letting access the key.
Quanticus. Why are you trying to reassign the key index?
I don't know. My brain do be kind of foggy here.
Okay. Quanticus. Key index gives you the encoded letters, so you can just add that directly to str.
So instead of key index plus equal key index, we should do string. String plus equals key index.
Quanticus.
Yes, but string starts out
as undefined. Quanticus.
Need to
fix that.
Well, it can't be an empty string.
Quanticus. It can be an empty string.
Are we gonna have to do two string function? String equal.
Quanticus. Know what you have, RN is fine.
I have right now is string plus key. Index eyes 5 tracks string
Quanticus. Plus A equals A.
What was that, Quanticus? Length string plus A. Okay. Length string plus A. So why is this undefined then? Where did our brute force function go? Didn't we have a brute force function here?
Quanticus. Cause you have key index equals message I, which is a letter.
Alright, I'm stumped, almighty wise one. What hints do you have for me now? What should we tackle next?
Quanticus. You get the key index from calling brute force.
Right, but where did our brute force call go? Deleted accident? To.
Quanticus.
Line 5,
Line 5 doesn't make sense
currently.
currently.
Let key index equal message I. Let key
Quanticus. Message I gives you a letter from the original message, not the index of the key.
Okay, message I different message, not the index.
Quanticus. Key I gives you a letter from the key.
Alright, message I gives you from the key. Think
Quanticus.
we
wrote a whole function to get the key index.
That's what I thought. That's what I was asking earlier. Didn't we have... yeah? It's doing something. Did a thing.
Quanticus. It's giving you everything except the special characters that we haven't handled yet.
Okay. You know, when I said the word something, I didn't mean I was oblivious to what I was doing, Quanticus. Okay, so I'm guessing it's like if the index is less than 0, then return this. Then well, key index. So if we do it this way, in theory, if there's no match, then return the special character, yeah? Or
Quanticus.
Do we need to set a default?
Now imagine the if check fails. That means message I is a special character. So what do you want to do in that case?
Then we want to give back the message index, right?
Quanticus. You don't need to do another if check.
Okay. Okay. Oh, okay, 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 okay. I'm just stupid. Okay. Just stupid. And string that message index. Yo. Okay. So we got that, but now we need to test for uppercase and lowercase.
Quanticus.
Whoa.
Whoa.
Whoa. I don't know why it said it like that. So now we need uppercase and lowercase. So are we going to need another separate function that handles uppercase to lowercase? Dude, I struggled for like 5 hours on this by myself, just so you know. Probably believe it.
Quanticus.
So before you
Before you add key index, you need to check if the original letter in the message was uppercase or lower.
Okay, so before you add key index, okay. So that's here. So before you add key index, we need to check if the original letter in the message was uppercase or lower. So if key index greater than 0, before need to check the original. Oh my goodness. Give me 1 second. So is it going to be like absolutely equals? Then don't change, but because like we would be checking absolutely equals for if it's a capital, but if it doesn't, then to lowercase the keys index.
Quanticus. Remember, if a character is lowercase it will be equals a end.
Okay, hold up. Alright, remember, if a character is lowercase, it'll be less than equal to lowercase a greater or greater than equals greater than equal to lowercase a and lowercase equal to lowercase c. Okay, so if key index is greater than equal to 0, and this would be going into line 7.
Quanticus. Line
Line
8.
8. Okay.
Restream.io.
Hey!
Trophy,
Made it to
congratulations.
100 messages today.
You've received 100 messages today with Restream Chat.
That's a pat on the back right there. Okay, so if key index is greater than equal to 0, and I'm trying to think about how to incorporate that. Character is lowercase. Into line 8. Because we're already in an if statement. Character is lowercase. Greater than equal. So are we using no. My brain is melting. If the original letter in the message index lowercase.
Quanticus.
The
If the original letter
is
is lowercase,
add the lowercase.
then you want to add the lowercase version of key index.
Yeah.
If not, then key index is already uppercase.
Yeah, we got that part. Oh, true. So if true. So if no, because it goes in line 9. Line 8. Alright. If the original letter lowercase, you want to add the Sorry, the bird's over there like squealing very quietly, and I go to look at it, and she goes, "What are you doing?" What are you doing? You sound like you're dying. Alright, back on track. If the original letter is lowercase, then you want to add the lowercase version of index. If not, then key index is already uppercase. Yeah, I'd understand if it was like line... No, I wouldn't even understand if it was line 7. Line 8. Monicus, the brain melting out my ears. If the original letter is lowercase, then you want to add the... So... E... No. Message... I... is greater than to lowercase a and message I is less than equal to lowercase d. Do this. Did I do that right? I don't think I did that right.
Quanticus. And it's perfectly legal to nest if statements.
You're kidding. You're kidding. See, that's where my brain was really confused. Well, how do you nest them? How do you nest them? I imagine something like this. Yeah.
Quanticus. Just make it an if statement.
So if gotten crazy. Else, so if message index string equals the index dot lowercase else string equals the index. Okay, hold up. Did not like that. The index that's lowercase is not a
Quanticus.
function.
The to lowercase goes outside the key.
Goes outside the. Alright, we're learning. At least we know it exists. We are more comfortable with trying to use it. Okay. So, guess help if I completed the function. Okay, I still did something wrong here.
Quanticus. And your is a little wonky.
Did I still put it in the wrong spot? And my curly bracket is a little wonky? What do you mean? What's wrong with my curly bracket? What's wrong with it? Because I'm not displaying it like I normally do.
Quanticus. It's key dot to lowercase.
It's really okay. It is E dot lower. Did not like that. I'm guessing you meant to put it at the end. Okay. No. Might be stupid again. Hold on. Nope. Stupid. Where? Yo. 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 You did it. You did it. Took ages, but we did it. I wish they had like a timer on it. On like, what would have been the appropriate amount of time to solve that challenge?
Quanticus. Now can you explain the code?
Bro, that's something. Alright. We have a function called substitution that takes in key and message. We have an empty a variable called string that is an empty string. We have a for loop that starts at the index starts at 0. If I is less than message.length, add 1 to I. But the code that we run, we have a variable called key index that calls the brute force function that we made with the argument of messages index, so that way it only does 1 at a time. And then we have an if statement for if key index is greater than or equal to 0, then run these the nested if else statement, which is if message index is greater than or equal to lowercase a and message index is less than equal to lowercase z. So this is checking to see if the messages index is in lowercase than, or I'm sorry, if messages index is lowercase. Yeah, if messages index is lowercase. Yeah, we're checking if messages index is lowercase. If so, then string equals, so we're adding to our empty string, key, the key array, we're checking the key array for the key index, and then we are using the to lowercase function to lowercase it, else we are we're adding to our string just the key index, since the message index is uppercase. We don't need to change that. Then else string, once everything is said and done, string equals message index. So this is for our special characters. So the ones that we just want to skip. Well, not skip, but we want to put in because, put the spaces where the spaces go. Doesn't need to be encrypted. And then we're console logging the string. And then we have our brute force function that takes in the message. Message equals message to uppercase.
Quanticus.
Nice.
Nice.
Message equals message to uppercase. Why did we have that here? Oh, because of our switches. That makes sense. Okay, so here we are making message all of them to uppercase. So that way when we run our switch function, which takes in the message, it is checking for all of the cases and returning a value for us to then run over our key later in the other function. Yeah. See, reading is one thing for me. Reading code is one thing. Writing code is another. I always wondered what this button does.
Quanticus.
Pretty simple
once it's all said and done yet?
Yeah, I mean, again, it's not really something I could do on my own, but I imagine over time I probably can. Brute force function is extremely inefficient. It uses a switch statement to compare each character against all 26 letters, which is a linear search. This will become extremely slow for larger messages. Additionally, using a switch statement for the kind of mapping is not good practice, as it's not scalable and can be difficult to maintain. A better approach would be the dictionary or map to store the letter to index mapping. The code exhibits some modularity with the separation of the substitution and brute force functions. However, the brute force function is tightly coupled to the specific tasks of mapping uppercase letters to their corresponding indices. This makes it inflexible and difficult to reuse for purpose. Additionally, the code lacks clear separation. Substitution function handles encryptic logic and character harder to modify or encryption without affecting parts of the code. Code is hard to follow due to several issues. Poor naming. Function brute force is a misnomer. It doesn't actually perform brute force, but simply maps letters to their corresponding index. Better name would be letter to index or get letter index. Unclear comments. Comment at the end of the vague. Doesn't really. You had to look at the comment. That was for my own personal use. Provide much use. Helpful to explain the logic of the code is structure. Brute force function. For some iterative. Up would have been more efficient. Clarity, the code would redundant logic. Here's the key. Here to lowercase would be simplified by the key to lowercase up front. Functional but lacks clarity and order. We did good. I don't care what that says. I found it funny. We did good. Quanticus did most of the work, but we did good. And we have a certi. So, modern JavaScript for beginners. Thank you, Jack. Your 2 challenges were very challenging. Okay, we'll end this on a daily. In 1 second, let me get the dogs. Stop whining. Look, we'll launch the daily. Booyah. Card number arranger. Create a function named range card numbers that receives numbers as its parameter. You and your friends are making greeting cards on a cozy afternoon. You want to arrange the special number. Birthdays, anniversaries, or lucky numbers on the card in a specific pattern. Your task is to arrange the numbers as follows. First, place all even numbers in ascending order. Then place all odd numbers ending. Numbers array, an array of integers or special on the card. Function returns a new array of numbers arranged according to the specific pattern. Okay. So let's array an empty array. So we have numbers is an array. I equals 0. I and number dot length. Add one to I. Log. Console log down. 1, 2, 3, 5. 5 times. Some point I'll know that. Okay, so we need to, it needs to be 2, 4, 5, 1. So evens going up, odds going down. So if numbers or if hold up, because I know it's going to be divided by 2. If numbers index divided by 2 greater than 1 or equal to 1. Oh my goodness. Hold up 1 second. Alright, so if that and array plus equals array. So hold up 2 or 5. Is it modulate?
Nihilgeist.
No.
Yer.
Not modulate. Grr. Hello. That was a word. Grr. Okay, maybe not modulate. Okay, so here's where the issue is coming into play. So 3 technically can store 2 1 time. So that's where the issue is coming.
Quanticus. It is percent, but ARR plus equals isn't doing what you intended.
Okay, thank you, Monicus. Alright, so it is modulate. Alright. But look, I'm learning.
Nihilgeist.
Hello.
Hello.
How are you? I hope you're doing good today. I hope you're having beautiful weather and beautiful times. It is modulate, but array plus equal isn't doing what you... Okay, so if array equals numbers index 2. Is it just numbers?
Quanticus. You can do plus equals if you were adding another array, but if you just want to add a single element, you have to use an array method.
So array, what is it? Dot pop numbers and was it not pop? Removes the last element. Okay. Dot push to ends new elements. End of an array. Turns the new. Well, we don't want it to return the length, do we? Yes. Okay. So we got 1, 3, 5. We're going backward. Shift. Moves the first element from an array and returns it. The array is empty. Undefined. Unshift. Ooh, not unshift shift. Inserts new elements at the start of it and returns the new. Okay, we still got 5, 3, 1. Why am I getting the odd numbers instead of the else? I mean, since we have those results anyway.
Quanticus.
Else.
When the remainder is equals 1, then it's odd.
Oh, okay. Alright, well, my math was off, but at least had the right shift number. Oh, okay, alright. Pop. Pop either. Okay. 5, 3, 1, 2, 4, and we want 2, 4, 5, 3, 1. Five, 4, 3. Or 5. How the hell does that work? Okay, so if we ended up with 5, 3,
Quanticus.
1 at the beginning.
Unshift if front of the array, push is the back of the array.
Okay, unshift if front of the array, push is back of the array. Okay, okay. So, well, the thing is, we want the odd numbers to descend in the back the way that it is. So we want this in the back. Push is back, shift is front. So push, unshift. Okay, have new results, not the right results. So 5, 3, 1 is backwards. When it'll go 5, 3, 1, 3, 5, and 2, 4 are backwards. Because why? So if we're going through clearing these,
Quanticus. It's right for this case only because the original array was sorted in ascending. It won't work for unordered numbers array.
wait for this only. The original array was sorted in ascending. You talking about the unshift? Which one do you think would be easier to get first? Even or the odds? Starting to think that if we start with the E,
Quanticus.
better off.
Check
Okay,
the other
that's
test cases.
But our 7. Let's fix that. Outable. What is it? Did get 1, that's right. 5, 3. Ascending. This is ascending instead of ascending.
Quanticus. You're separating the evens and odds, but they're not sorted.
Separating them.
Quanticus. Can you see why it doesn't work with unsorted arrays?
Are we talking about the unshift and the push, or the sort methods? Because if we're talking about the sort method, I think it's going to the whole array. Yeah, it takes the whole array. We sorted it. If x 2 Am I on the right track?
Quanticus. But do you want it ascending or descending anyway? If you're able to answer that, then it means you can correctly visualize how your code builds the new ARR with each iteration.
But do you think why? Y. Birthdays. First, all even number. No. That's why. Because it tells me to.
Quanticus. We can do an exercise in Paint if it helps. Quanticus. Write out 1 to 5 ascending.
Five.
Quanticus. Now the area below this will represent our growing array. Quanticus. On the first iteration we look at 1. Quanticus. So do we push that to the back or unshift to the front?
To the back. To the back. Odd.
Quanticus. Now look at 2, push or unshift.
Unshift.
Quanticus. Just write out the order of the numbers in the new array. Quanticus. Write 8.
Sorry. 5.
Quanticus. No.
No. I was wrong.
Quanticus. Do it one at a time. Quanticus. I starts with 1.
Oh. How far back? 1. First iteration.
Quanticus. Now add 2 to the front. Quanticus. So it's 2, 1.
Yeah. Oh, it's 2, 2, be nice if the rules ain't hate me. Okay. 1.
Quanticus. Then add 3 to the back, it becomes 2, 1, 3.
3.
Quanticus. Then 4 to the front.
2.
Quanticus. 4, 2, 1, 3.
Thank you. 4, 1. Okay.
Quanticus. Then where does the 5 go?
Very end.
Quanticus. This doesn't match what the challenge wants. Now try it starting with 5, 4, 3, 2, 1.
Okay. So 5, 4, 3. Okay. Start with 5. It's gonna be 5. 4 is gonna go before the 5. Then we're on 3. So it's gonna go either at the beginning or at the end. If it's odd, it's gonna go. So 4, 3. We're on 2, so 2, 4, 5, 3. And then 1, 2, 5, 2, 4, 5, 1, which is what the challenge was. Oh.
Quanticus. Now it matches.
Now it matches, yeah. Oh. So we need to sort it in reverse. So there is a reverse. No, that didn't work as planned. What did it do? Log numbers. Get rid of that one. Let's see, what did it do?
Quanticus. I think reverse will just reverse the current order without sorting it.
5, 4, 3, 2, 1, 1, 2, 3, 4, 5, 5, 4, 3, 2, 1, 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Because I put it in the for loop. It's gonna be all kinds of wonky. Five, 4, 3, 2, 1. But we want it to be 5, 4, 3, 2, 1. Yeah. Or 3, 2, 1. Two, 4, 5, 3, 1. Okay, so it was right for this one, and this one, but not this one or this one. So we got 10, 8, 6, 2, 9, 3, 7 when it should have been 2, 6, 8, 10, 9, 3, 7. And 10, 8, 6, 4, 2. We got 2, 4, 6, 8, 10, 9. No, this was expected out. We got 10, 8, 6, 4, 2, 1, 3, 5, 7, 9. So it's not always the case. So this one's already reversed. So if it's reversed, it's going to get reversed again. And this is a big brain challenge for easy.
You will need to either sort before reverse, or make the sort go backwards.
Okay, so numbers equal numbers dot sort. I think I misunderstood what you meant, but I think I understand what you mean now. So you're saying that we're going to need two conditions, one that sorts and one that reverses, not sort and then reverse.
Quanticus. What you have is what I
Oh,
meant.
what I have is what you meant. Okay. Yeah, we're still failing. So, and we're failing because 10, 7, 8, 3, 6, 2, 9. We're outputting 10, which is right, but we're getting a 2, 6. Or no. Not right. It's wrong. 2 should be first. 2, 6, 8, 10. And then 9, 7, 3. 9, 7, 3 came out fine.
Quanticus.
But the 8 and the 10.
Can you close out of Paint? I can't see what went wrong.
Oh, my bad. I completely forgot that My bad. So 10 is misplaced. Other than that, everything was fine, but 10 is misplaced.
Quanticus. 10.
Less than 2, because sort with no arguments sorts by alphabetical order. Okay, hold up. 10 less than 2, because sort no arguments sorts by alphabetical order. Okay. Take a look at that. Numeric sorts. Function in this. Find the lowest value, highest value, highest value. Dot sort. So numbers dot sort. What? Function. Parameter. And 8. Do I need to pass in the function? No arguments. Numbers dot sort.
Quanticus.
Yeah, pass
in the function like they have written.
Okay. Do I pass in my current function? Arrange hard numbers. arguments. What would I do as the arguments? Numbers?
Quanticus.
No,
No, it's an anonymous function you can
Okay.
copy and paste.
Okay. And B minus it. That too. What is A and B?
Quanticus. Since it's already descending, you can remove the reverse.
B minus A. I imagine we need to change these to something. Numbers, that sort, that calls in. Oh, we don't need that. Okay. Okay, all of them but one. How does it know what A and B is? How did that work? I feel like it broke the code. Oh, what? -5, -4, -3. I only got one wrong.
Quanticus. The anonymous function is something that the sort function calls.
What the sort function calls. Okay. The anonymous function is something that the sort function
Quanticus.
calls.
You don't need around the entire function.
You don't need brackets. What function? Where do I have brackets?
Quanticus. I mean.
Oh. Is it breaking something? Talk about for the return? Doesn't like that. Don't need curly brackets around the end. I didn't like it when I took it from the return.
Quanticus. The return needs it but not the entire function itself.
Those are the only ones, that's the only spot I see the curly brackets. Or parentheses.
Quanticus. Oh, I can't call if it's, or either way you can lose the extra, around the function.
Gotcha. Gotcha. So we don't need it wrapped. Okay. Well, we're still running into an issue with this last test. -4, -2. Didn't get the -5 or the negative or the negative or the -1 where it was supposed to be.
Quanticus. The remainder doesn't work with numbers, you have to account for that.
Oh. Okay. How do we account for that? An or? Oh.
Quanticus. Add an OR, yep.
Or so this is for our if numbers I well, that pushes at the end. Okay, there we go. So that I at least got the negatives first. Well, no, because it doesn't want all of the negatives together. Because it wants -4, -2, 0, 2, 4, 5, 3, 1, -1, -3, -5. So we still want divisible by 2 first.
Quanticus. I usually do if %2 == 0, then it's even.
If okay, hold on. Divisible by 2, 0. That was closer. Got -5, -3, -1 together. I was thinking.
Quanticus. That's checking for odds though.
Okay, that one. Okay, I usually do if this, it's even. Are you saying to replace my whole if statement with that? And flipperino the push and unshift? Alright, I'll figure it out in just a second. Alright, Quanticus, we're gonna put this one on the back burner for tomorrow. We are a little bit over my usual amount of time. So I'm gonna pop off. I'm gonna get some food. Might be a little bit of the reason why I'm kind of slacking behind here. But we can continue it tomorrow. You pop in. I'll save it for then. Other than that, I'll just be going through the courses.
Alrighty.
But I appreciate you popping in. I appreciate us, being able to get through that challenge together again. It's more 70% you and 30% me, but we're getting there. We're getting places. The brain's thinking. So I appreciate you coming by, and I hope that you all have yourselves a great day.